Hey, welcome back to the lecture. So now let's do an exercise. So the exercise is write a program to maintain records of students. The program must maintain records of 10 students and you should give below features to your program. So you should be able to display all the records. You should give the feature for adding a new record, delete a record. So all these provisions you should give to your application. The program also should avoid or alert about the below situations like duplication of a record, no space to add a new record, deleting an unknown record. So these cases should be taken care. Let me show you some demo. You will get some hints. So I have already wrote that application. So it's a very straightforward application. You need not to worry too much. So first you should give this menu to the user. So actually I have given 4 options: display all records, add, delete, and exit the application. Let's say user enters the menu code 1. Here you can see that it is saying no records found. Why? Because I have not added any records, isn't it? If I give the menu option 3, so that is actually deleting a record. Enter the roll number of the student. Let me add one roll number, and here you can see that it says record not found. Let me type 2 to add a new record. Enter the roll number. Let me add 6789. Then it should ask user to enter the student semester. Let me add 7 and the date of birth 1987. So you should add in this format. And after that, student branch, let's add computer science. And after that, student name, let me add my name. And it says record added successfully. And after that, you can now press 1 to display the record. So here it is. This is a record, right? And after that, you can type 3 to delete a record. Let me add 89 and record not found. And if I try to add the same record once again, it should alert me about the duplication. For example, let me add the record, same 6789, and it should say that roll number already exists. Record add unsuccessful. So now let me type 3 to delete a record, and let me add 6789 and record deleted successfully. So like that. So that's a small demo. So it's a very simple application, so you should be able to do. So, but let me give you some hints. So for this application, you should be using a structure, type def structure, if you want to maintain a student record. A student record should contain the below information like a roll number as an integer, some char arrays for name, branch, and date of birth, and some integer to store the semester information or whatever the information. You are free to add more information. So reserve space to hold 10 students' records. So how do you reserve the space? There are various methods like using dynamic memory allocation and other things. So, but we have not yet covered those things. So we should be using a global array of structure, which is something like this. Very simple. So you have int a10. So if you have this, so this is a integer array, right? So similarly, this is a structure array. That's it. Instead of integer, you have your user defined data type. That is this structure, isn't it? You should maintain this array in global space. So this is how a structure array looks like. So just compare this with an integer array or a char array. So there is nothing special about this. So this is actually the element 0 of the array, which is able to hold one student record, and this is able to hold another student record, like that. So there are 10 such elements. And this is actually the array variable, which is pointing to the base address of the array. So if you do a students plus plus, what happens? It will be incremented by the size of this array, isn't it? So that's why it will be pointing here like that. So here students is a variable of type student underscore info underscore t star. Let me talk about how you should add a record. So this is just my rules. You can implement your own rules. There is absolutely no reason why you should follow this method. You can implement the way you like. But so let me explain how the code is implemented. But let me give you some hints. First, find out the empty element in an array. Empty element you have to find out. So I will call it as an empty node. So whether a node in an array is empty or not is decided by the roll number field. So if the roll number is 0, consider that node is empty and a new record can be added. Also, the user given roll number should not match with other existing roll numbers, otherwise it will be considered as a duplication and record should not be added. So that's how you add a record. How do you delete a record? So ask the user to enter the roll number of the student. Match the user entered roll number with the existing roll numbers of the nodes. If a match is found, then zero out all the member elements of the node. So remember that deleting means zeroing all the member elements of a node. So that's what delete means. Let's move forward. So before you start coding, let me explain one more thing about accessing structure array elements using structure pointer. So now let me quickly talk about accessing structure array elements using structure pointer before you start doing the exercise, because this you will be using while you start coding for the application. Let's consider there is a typedef structure, and let's say I create a global array of this type. Let me give the data type. Let me create the variable students of 2, let's say. So this is an array of 2 elements, right, of type student underscore info underscore t, right? Let's initialize this array. So in your program, you should not initialize like this. You should take the information from the user by reading through scanf. But in this case, I'll just initialize here itself. So you have to open and close the curly braces, and here you have to initialize. You can initialize both elements. So now let's open one more curly braces, and here we will be initializing array element 0, and you can give comma, and here we will be initializing array element 1. You can do something like this. That is fine. Let's start initializing the first element. So roll number, that is actually an integer. Let me give some number. And second one is name. Let me give Ashok Kumar, and after that third one is branch. Let me give mechanical, and after that you can give comma and give date of birth. Let's say 12/11/1999, and semester is an integer, so let's give 7. So after that you can continue here itself for the second element, but instead of that you can press enter here, and after that you can write the initialization for array element 1 here. Let's change the name. Let's say Ram Kumar, and let's say this is computer and some number. So now you can also arrange something like this. What you do is you just give enter here. So you can align these two. This one, this is for the first element, this is for the second element, and you can give enter here. Or you can also do something like this. So this looks good, isn't it? Let's try to compile this. Right, so no problem with that. And after that, let's create a display function. Display all records function. So, and we are going to call this display all records from the main. Fine. So as an argument, and the argument of this function would be the base address of this array. So that is students. And after that, the maximum record. So the max record is 2. You can also create one global integer max record is equal to 2, or you can also do hash define max record, but I have not yet covered macros. So if you know macros, you can do something like this, or you can create one global integer, maybe a const integer, something like that. And after that, you also have to send this max record to the display function. So the first receiving parameter would be student info t star. Let me call it as p base address or p base address of records, and the second parameter would be int max record. So now the question is, in this function you only have this pointer variable, right, which actually holds the base address of the student's information. Now the question is, by using this pointer, how do you access different elements of the structure array? So this is the element 0, this is the element 1, and you now have the base address, that is this one. So how do you access this element, and inside this element how do you access these member elements, and how do you access this element using the base address, and in this element how do you access different member elements? that we have to understand. This is a pointer variable of type structure, right? And according to our earlier discussion, whenever you have a pointer to a structure, you should use what? You should use an arrow operator, right, to access the member elements. So that's why you can use arrow operator here. So now let's say I want to print the roll number of the 0th element. What I would do is I will just use printf roll number of first or roll number of 0th element of the array is equal to %d/n. So I would use this base address arrow operator. I would select roll number, right? That's it. So now what if I want to print the roll number of the first element? This is the first element. This is the 0th element. So let me change the number to something different. So what would you do? You would be doing this one, right? So you would be doing ++. You have to move this pointer to here, right? So you have to do ++. So when you do ++, it will be incremented by the size of the structure according to pointer operation rule, right? So I would be doing this one. After that, again, let's print. So roll number of the first element of the array is equal to this one. Let's check what happens. Let's build the project and let's run. Yes, we got the answer 98768888. That's perfectly fine. But what if the max record is 100? So will you keep printing like this? No, you should be using a loop, right? Let's try the same thing by loop. What I would be using is for u in 32_t, I is equal to 0, I is less than max record, I ++. So I would be doing something like this. I would be keeping this printf here, printf roll number of %d element of the array is equal to %d. So here I would be printing I and this one. So here what you should do is base address plus I, isn't it? Makes sense, right? So just closely observe this code. Roll number of %d element of the array is equal to %d. So base address plus I, arrow operator roll number, right? So let's see what happens here. So let's run this code. Right. So here it is. There is a problem. I'm sorry about that. So what happened was here actually it is incremented. So we have to switch this code off. I'll just comment this code. I'm sorry about that. So let's comment this out. Let's run once again. That's correct, right? So roll number of 0 element of the array is 9876 and roll number of first element of the array is equal to 8888. So you can do something like this. So here you can justify using the arrow operator because this is a pointer to a structure, isn't it? So that's the reason you have to use the arrow operator. So instead of doing this, you can also do it using dot operator. For that, what you have to do is you have to do something like this. So let's remove this. So for that, you have to use base address of I and then select the member element, right? So here why we are using dot operator? Because this entity is not a pointer. Remember that. This is non-pointer. So that's the reason why we should use dot operator here. So remember from our earlier array pointer discussion when we had uint 8 star and the pointer, we actually accessed different array elements using this notation, right? So that same logic you can also leverage for structure pointers as well. So what is this one actually? So can you recall from your array discussion? This is nothing but I can rewrite something like this. So this is actually equivalent to this code, right? Star of code plus I, right? So this is actually equivalent to this one, right? Just recall this from our earlier array manipulation methods, right? So that's why I can replace this here. I can do this. So, but you cannot simply do like this. You have to give one more parenthesis here. Right. So take a look into this one. So this is equivalent to this one. So this is just for your information. So you need not to write something like this because this looks very confusing and even though this syntax is correct, it doesn't make people comfortable, right? So that's why let's use the easiest method. That is just take the base address of I and use this with a dot operator. That would be the very easiest method instead of doing all these things, incrementing stubs and all. So this would be the best method, I guess. So, but all the other cases what we discussed are equivalent codes. They are one and the same. So that's why we would be manipulating different structure array elements using this method. So when a structure pointer is given. So now let's check this code. Let's run once again. Right, so this is also same, no problem. Fair enough. So why I explained all these things, because you would be doing something similar in the project which you are going to implement next. Now you can start implementing this program. So take a look into the resource section of this lecture. I have attached two files for you. One is the starter code. So the starter file is implemented partially and I have given various to-dos for you. So you can refer to the starter code only if you are not confident about coding this program. If you need some initial hints, you can refer to the starter code. Otherwise, need not to refer it. You can straight away start coding. And the second file is a complete solution, which you can refer and you can compare with your logic. And the logic can be anything. You need not to follow what instructor has said. You can implement your own ideas, no problem. And with that note, I would like to end this video. And this also completes discussion on arrays and strings. And I'll see you in the next section.